name is Karan, and today on SmartAlgoAcademy, we will learn how to backtest EMA crossover strategy. So let's get started. So first what we're gonna do, we're gonna create a virtual environment. So in order to create that, you have to do Python env, and this will create a virtual environment. Of course, after creating the virtual environment, let's create a new file. I'm gonna call it ema1.py. So this is our file is created, and let's set up our virtual environment. Now as you can see, our virtual environment is on because you can see this env. So let's install certain libraries before get started. So we're gonna install Pandas. We need the data, so we're gonna get the data from Yahoo Finance. So we only need these two libraries, Pandas and Yahoo Finance. So as you can see, we have installed these two libraries, Pandas and Yahoo Finance, and once you're gonna install it, let's get started. So first what we're gonna do, we need Pandas. So we're gonna add Pandas in here, and we need Yahoo Finance. So why Finance? So we're gonna download the data from here. So let's first download the data. In order to download data, we will need yahoo.download, and which ticker you want to download. So let's download for Apple, and I want to download 1 minute of data. So I'm gonna set the interval to 1 minute, and I need the last 7 days of data. So I'm gonna set period to last 7 days. And multi-level index, I do not want that. If you are using the older version of Yahoo Finance, you won't gonna find this. But in the end, when you download the data, the downloaded data should look something like this. So as you can see, we have downloaded the data, and the downloaded data should look something like this. So we have open, high, low, close, and volume, and the date time is. So once we have this, we need two EMAs to cross over. So first EMA should be EMA of 1, and this EMA should be DF of, and we're gonna create the EMA based on close values. So I'm gonna say this clause, and then what we need, I need a span. So let's say EMA of 9, I need that. And then what I'm gonna do, I'm gonna simply just do mean, and this will create me one EMA. So let's see whether it's actually creating one EMA or not. So as you can see, I have created an EMA and it's downloading, and I will simply just print it, and we don't need this anymore. If I print this, as you can see, this EMA is calculated in here. So we have our first EMA. Let's create our second EMA, and our second EMA should be, let's say, of 26, and I'm gonna call it EMA 2. So as you can see, we have EMA 1 and EMA 2, both of these are here. So we have our two EMAs. Now what we need to do, we have to backtest this. So like if the first EMA is crosses above the second EMA, then we're gonna buy, otherwise sell. So in order to do that, first we need the trades. Let's create a trades list, and we're gonna iterate the data frame. So in order to iterate, we need one current date time and the row in df.iter rows. So as you can see, we are iterating through the rows one by one. Now if our position is not none, then we're gonna check for exit, check for entry. Our position is not empty, otherwise we're gonna check for exit. So this is good. So let's create one position object. So at the starting of the simulation, of course, we won't be having one position, so we're going to check for entry. So how we're going to check for entry? So if our row of EMA1 is greater than a row of EMA2. If this is the one, then we're gonna check that this is the entry signal and we're gonna create our position. So we will have entry date. Our entry date will be the current date time. Then we're gonna have an exit date. But of course we don't know when it will gonna exit, so we're gonna simply just set it to none. Then we need a symbol. So of course, what's our symbol? Our symbol is a APL apple. Our side, let's say we want to buy. So when we're gonna enter it, the side we set is buy. Then we need an entry price, of course. So what will be our entry price? So let's say we are running this whole EMA on a closing period. So our entry price should be closed. It should not be open because we have calculated the EMA based on close. So we are thinking that our strategy is running based on close values. Then we need the exit price, but of course we will not have any exit price because we don't know when it's gonna exit. And if you want to add, you can add a quantity, but for now I'm adding quantity is equal to 1. So this is it. So let's say we are currently in a position because this position is created. So next time we iterate, this will gonna false and we're gonna go for the exit. Now in the exit part, let's check if EMA of 1, row of 1 is less than row of EMA 2. If this is the case, then what we're gonna do, we're gonna simply, we already have a position object. We only need the exit date, and what will be our exit date? It will be our current date time and position of exit price. So what will be our exit price? It will be a row of close. Yes, so we have these two. Now what we're gonna do, we're gonna simply just add this to a trades.append and we're gonna add this position.copy. I want to make a copy so that we don't face any readable issues. After that, simply just create this empty object. Okay, so let's say we are iterating it, and at the end of the iteration we will have some trades. So let's say if we have some trades or not. So as you can see, we are downloaded and we have some trades, but this doesn't look so good. So let's create these trades into a trades of data frame. So pd.data frame, and we're gonna add the trades, and let's print this trades data frame. And this data frame should give us all of this data. So as you can see, we have entered at 1331 and we have exited at 1406, and our time zone is UTC time zone, so please make sure in mind. So it happened the crossover, the EMA crossover at 1331 and EMA cross below at 1460, and we have entered at 212.25 and we have exited at 214.30. So we have exit price and entry price. Let's now backtest it. So first what we need the absolute dollar value. So what is the PNL of absolute? It's exit minus entry, right? So exit price minus entry price. But of course we have a quantity as well, right? So we're gonna multiply this by quantity because if we have two quantities, then it should be multiplied by that. So as you can see, if we now run the system, we will have absolute, like we have made $2 in this, we have negative 13 cents. So this is all that. Now I need the percentage of every trade as well. So let's check. So for the percentage, we will simply just create a new column of PNL. So entry minus exit and divided by PNL of entry price. And we have to multiply this by 100, and if we run this, we will have a percentage as well. Exit. Okay, okay. So as you can see, we made 90.96% profit and 0.06% loss and all. Okay, so this is it. Now we need to see whether our trades which we have made is winning trades or losing trades. So how we're gonna do? So let's import Numpy, because Numpy has that boolean value. So np.where if a trades of PNL absolute is greater than 0, which means we have made profit. So we're gonna say win, otherwise it's lose. Even if, let's say, if our PNL absolute is 0, our entry price and exit price are same, so we haven't made any profit, still we're gonna say it's a lose, because we will be paying taxes and fees, so it will be a losing trade for us. So as you can see, we have a winning trades and we have losing trades, and with this information you can create whether we have made a profit or loss. So this is a basic backtesting of how we're gonna do and all. Once you're gonna do this backtesting, then you can create a lots of different scenarios of return on investment or maximum drawdown or winning ratios, losing ratios, risk to reward ratios, Sharpe, number of trades, what's the accuracy of it and all of that. But this is the basic backtesting of EMA crossover. I'll leave my video to it, and I want you to learn how this gonna work. Thank you so much, guys. Bye bye.